Howdy, fellow Woodgas bug bite victims. Here's a little update on the MixMaster system. You may remember this little machine that was showcased a little while ago. It had a computer situated here which operated through this onto these valves. These 4 valves gave me 16 steps of airflow regulation and administered the air out of here to the engine, thereby allowing the computer to control the mixture and maintain it within set limits. It turns out that this was never really wide enough in the working range. The 16 steps were just not enough for this little engine. To get round that problem, I've come up with this version. It's all based on a scientific principle known as squeeze. What happens is this flexible pipe here gets squashed by this arm. So as the motor operates the arm, you'll see it moving there as I turn the motor, and you'll see also as the arm operates, it squeezes that pipe. At the moment it's fully squeezed shut, so the engine can't draw any air through this air filter. This air filter is a dual purpose sort of thing. It serves as a backstop for the compressor arm here, so the pipe will be squeezed against it, plus it also serves as the air filter medium container. This is the stuff that's in it. I took that out of my pillow. The scientific term for this is white fluffy stuff. Just remember that, because there will be a test at the end of this. So in practice, when the oxygen sensor wants the mixture to get leaner, he'll start turning the motor and releasing the pressure on that squeezy tube, and vice versa. If the mixture gets a bit too lean, it starts cutting off the air. That air is taken around the corner and down to the engine's intake. Right there. That's where the vacuum is going to be maximal. In the earlier installation, I had the air for the engine coming in here, just after the manual mixer valve, and the supply for the metering box on the Mark I version was provided by this. Turns out though that there was a vacuum on this, which I didn't realise was the case, and that was actually working against the working range of the Mark I system. So I've learned my lesson and implemented the improvements with this. Let's put some electricities in. Here we go. Just plug this little puppy in. There we go. That was a little preamble to demonstrate to the user that the motor works. There's a stepper motor down here. This replaces the 4 solenoid valves from the Mark I version. To regulate current to the stepper motor, I programmed the computer to deliver pulse width modulation control sequences so this doesn't burn up. And just in case I make a mistake with the programming, this little fuse will valiantly give of its life to keep my computer from melting. Just turn on the manual, go to auto mode from manual, and as before we can see on this little bit here that this light has come on. That represents the heater of our oxygen sensor, and this potentiometer here represents the oxygen sensor's output signal. So if I turn it, you're going to see a response there from the virtual meter. This is programmed to run for about a minute before it times out, which should be sufficient time for the heater in the oxygen sensor to become active. Ideally, what this should mean once I get this thing working, and this has never been tested, I've installed it just like 10 minutes ago, it should replace this valve here. It should have the ability to compensate for any adjustments I make on this, within reason of course, so that even if I go so far as to close it completely, this will simply open up to make up for it, as that now becomes my air control system. Okay, the timeout has run to completion, and right now, because it thinks the mixture is lean, this is trying to squeeze even more on the pipe, which is already squashed flat. You can probably see now why this doesn't have teeth going beyond a certain point. I've set it up so as it will literally crash into the end of the gear box, I guess you'd say, when it reaches the limit. Now if I turn this to simulate the mixture getting a little bit richer, give it a moment to turn it some more, there we go. Right, the computer is now indicating a reversed trend here, and because the mixture is only very slightly getting rich, it's reacting very slowly, very slowly, opening this to add more air. You can barely see it moving. I don't know if the camera's even picking that up. But now, if the mixture gets richer, for whatever reason, the system reacts faster. And then the mixture starts to lean out because, hey, that's reacted enough. Finally gets to the point where it's a bit too lean. So the system slowly compensates, winding it back the other way. It all depends on that valve. I mean, that bit of flexible pipe right there now, as that has become the equivalent of this valve, which in the past I was going to motorise, but then realised that the constant movement would wear it out. My thinking is that this won't wear out in such a way that it will put debris into the engine. Instead, it will simply fail. When it reaches the point of wear, it will fail. The engine will suck a whole bunch of air and it will stop, thereby protecting it from damage. That's the theory, Mr. McCleary. Now let's say this gets extremely super duper rich. Whee! You see how much faster that went. I've got it arranged in basically 3 gradients. So when the mixture's kind of lean down here, it starts, or I mean rich to this level, it starts to compensate slowly. If it gets a bit more richer, like up here, it compensates a bit faster. And if it gets really rich, like I'm not, it will compensate as fast as it can. That's the theory. That's pretty much how I did this. And it worked pretty well first time within its mechanical capabilities. So that's how it is at the moment. As I say, it's untested. This is its first sip of electricity from the battery on this machine. So I'm looking forward to running this engine up and seeing whether this actually works. Theoretically, because this has a much greater air handling capacity, it's possible for this system to actually stall the engine by causing it to go too lean. Plus also it's capable of going too rich. So if my programming is wrong, or the gradient or the attack speed on this is wrong, then yep, I'll be constantly stalling the engine like a learner driver in a manual car. Oh, anyway, boys and girls, that's a little preview of this little beastie. I'm just hoping that it actually works, as that would definitely make my day. So stay tuned, boys and girls, when I set fire to this engine. You're not going to believe this, but it works. Huh. Oh. 500 watt loads are now. I can't plug it into the house because the batteries are already full. But look at this, it's actually working. If I manually mess up the mixture, let's see what happens. I'm going to lean it out now. got a problem here. Oh no, it seems to be working. Just give it a moment to catch up. Thought the stepper motor had stopped, but no. Look at that. Here it is. So it's back to where it was before. Pretty near the end of the range though. So let's see what happens if I make the mixture go rich. That seems to have compensated for that by itself, that's good. Let's see what happens if I shake it up, eh? Shake the hopper. That made it go really rich for a few moments. But the system compensated. Well, this is a big improvement over the Mark I system. Not perfect, but for its first off test, I'm pretty pleased. Let's stop the engine for a moment by making it massively lean. There's no way the system can compensate for that, as I've just opened the air valve completely. But you'll see, because it thinks the engine is still going, as I haven't programmed it to notice the difference, it's trying to squeeze the air pipe to compensate. Well, that's pretty good. I think it needs a few little tweaks in the software, but I think I'm pretty much home and hosed with this. It now has much wider range than the first system. It doesn't seem to be able to handle this valve being fully closed, but that could be because I packed the filter too tight. I did notice that when I tried to breathe through that pipe, it didn't breathe too well with this wide open. So I'll perhaps improve on the design of the filter there and make it so as it's possible to have this fully closed, and then theoretically this will be able to make it so I can start the engine. Just push the button and all I have to do is turn on the gas, not have to worry about the airflow. When I turn on the gas and push this, this will sense that the engine is starting too rich, too lean or whatever, and compensate and allow starting to make it so good that it'll be much like a standard gasoline powered engine. Well, that's the theory. So time will tell as to whether this is actually going to stand up to long running, as these days I'm not actually using this machine very much. We done got us some sunshine now, and that's keeping our solar panels, some of which you can see there, keeping them plenty busy and keeping my batteries full, keeping my beer cold. Oh yes, by the way, see that little shed there? That's a little thing I've been building. That's been my summer project and winter project for this year, and it's coming near to being finished. It should be finished, looking at my calendar, let's see, yep, $2,000 from now. Oh, projects. Time. Where is the time? So fellas and fella S's, that's the Mark II system right there. I call it the SqueezeMaster9000 for perhaps obvious reasons. Hope you like it, boys and girls. Adios. Just a little add-on to the video. I managed to adjust this so that I can completely close the manual air control valve and have it keep going. This is fully closed now, and the only air for the engine is coming through this system. Turns out that the filter is too tightly packed and I've got to redesign that. Fairly easy to do though. Watch this. Well, wait for it to settle first. But give this a push. It goes mega rich and the system compensates as quickly as it can. Now that it's going lean, it's slowly enriching the mixture to get back to the sweet spot. It's a bit steamy down there. There's plenty of room for improvement in the software on the computer, but this actually works well enough that I can leave it alone now. Ain't that great? So now when I mess with this valve, not too quickly of course, the system should compensate. Well, looks like I messed with it a bit too fast. Let's see if I can start this using just this to control it. Wow, it worked! Haha! Sweet as! That actually started and regulated by itself. Amazing! The robot revolution is beginning. Well, I started that with the valve completely closed, and this made up the difference. It wasn't perfect, but it worked. Yippee! Okay, let's see what happens when I shake up the hopper now that it's reached equilibrium again. Shaking it up makes it go rich and the system compensates. Yippee! I have succeeded in making this automatic. Sure, it's not perfect, but wow, what an improvement over what I had before. Alrighty, boys and girls, time to run away. Bye-bye. You'll come back now, you hear?